Hello, and welcome to the Graphomate for UI5 tutorial, where we explain the basic steps to use Graphomate tables and charts and how to solve common data mapping tasks. The Graphomate charts and tables for UI5 come with an extensive documentation for each exposed class. It features small examples and an overview of properties, as well as events and aggregations. Most of our components are based on UI5 classes, like the abstract control, in order to inherit all functionalities from them. So keep in mind that our documentation only extends the base documentation of UI5. Here you can read about all inherited functionalities. In this tutorial, we'll use SAP Web IDE Full Stack and assume a basic knowledge of UI5 concepts. We start this tutorial by using the wizard to create a project from the template called UI5 application. We select a name and a namespace and use default settings for the other steps. Now that we've created a project, it's time to add the Graphomate component library. Therefore, we import the zip file, which is part of each release of Graphomate for UI5, and extract it to the project's web app directory. The project structure should look like this. Now we have to register the imported Graphomate components to the app by opening the manifest.json and adding the imported Graphomate libraries directory to a property called resource routes. This declares the location of our extension. Additionally, we have to add the extensions we want to use to the list of libraries. This makes sure the libraries get loaded to be available in the app. Now we are ready to add data. Therefore, we switch to the manifest's descriptor editor and add an OData service. In this tutorial, we'll use an OData reference service called Northwind. To access it from within the app, we have to use a proxy server due to the browser's same origin policy. Using the cloud platform, we are able to set up a so-called destination to forward the requests to the OData service. I have already created a destination to services.odata.org that we can select in the Web IDE. This makes all requests relative to the destination's base URL. So we can add the relative part of the service URL to the second input field and test the connection to retrieve the service metadata. Our goal is to visualize products and their attributes, units in stock, and reorder level, along with their product name in a hierarchy based on product categories. We finish the wizard without changing any other settings. After connecting a data source, it's time to create an actual Graphomate table in the view file. We add a namespace alias for the Graphomate tables to shorten tag names. Then we add a flexbox to center the table horizontally. Now we create the actual table with an ID and a specific width and height. We activate the native filter box and add a number format without any decimal places, because we want to visualize product quantities. We also add two data columns and a deviation column to the aggregation called columns. The first column will display the product's attribute units in stock. The second one will display the product's reorder level. The deviation column is meant to display the variance between both values, to give an overview of how many items are left until reorder should be commissioned. The only thing missing are row objects filled with data, which should be added to the rows aggregation. We will add them dynamically in the controller file, cause the data structure provided by this OData service can't be bound directly to the rows aggregation due to multiple hierarchy levels. In the controller file, we will do three things, which includes creating an OData model that requests specific product data, parsing the OData service's response to dynamically add row objects to the table, and configuring the deviation column. First, we need to import the OData model class matching the service version. In the onInit lifecycle function, we instantiate the OData model using the destination name and the relative service URL. We send a request for all product categories to the OData service by calling the read method of the OData model. The expand parameter populates the category objects with actual products. The select parameter includes all needed information in the response. These are the categories and products name, as well as products attributes, units in stock, and reorder level. Moreover, we add a success handler, which will be executed when the response is received. The success handler, called updateData, will receive the response of the OData service and add the data to the table. Therefore, we need to select the table. In case there already are row objects, we remove them from the table to start with an empty aggregation. Now we iterate over the response's category objects and add a row for each product category. The row class needs to be imported as well. The row instances include the product category's name, its hierarchy level, and data, which we set to 0 for each column for simplicity. Then we implement an inner loop to add the actual products to the second hierarchy level. For each category, this loop iterates over all products and creates a row including the product's name, hierarchy level, and the data we want to display. Products will be displayed at the second hierarchy level, and the data will be units in stock for the first column and reorder level for the second. When running the app in sandbox mode, the table correctly visualizes the selected data, but the deviation column is still empty. That's because we need to specify the IDs of the base and measure column used for calculating the deviation. We need to do this manually in the controller file, because the IDs we assign to the two data columns in the view unfortunately get prefixed by UEFI and aren't reliably the exact strings we set. So in the onAfterRendering function, we need to convert the data column's IDs to the prefixed ones by using the method byId from the view. We select the deviation column and set its measure and base column IDs to the prefixed IDs of the data columns, which we receive by using the method getID. Now, the deviation should be displayed correctly. The resulting table shows all products by category, and you are able to search the products. After building a simple table, we'll now look into a basic example of a Graphomate chart. We start by adding a namespace alias for the charts to our view. The chart will be rendered in a flexbox to center it horizontally. It gets an ID, a specific width and height, a rotated orientation cause it displays structural instead of temporal data, and we set the number format to not include any decimal places. Using the aggregation called deviations, we can add a deviation chart. We add an absolute and a percentage one. Now you could bind data to your chart in the view, but we will add it manually in the controller to show how to work with a model structure that can't be bound directly to the chart. We use the same data we visualized in the tables example and extract all products of the first product category for simplicity. The data can be set to the selected chart instance using the data series setter. The chart's data series accepts an array of floats, so we implement a helper function to map from an array of product objects to an array of product attribute values. This reduces the data extraction down to one line of code per data series. The first data series displays the beverages attribute units in stock, while the second one displays the reorder level. Category labels can be added using the same helper function to extract the beverages names. Please note the multidimensional structure of category labels. That's why we need to add an additional pair of array brackets in this one-dimensional example. When executed in the sandbox, this code renders a basic Graphomate chart consisting of a base and two deviation charts. The Graphomate charts and tables have an extensive set of properties to further customize their appearance. Please refer to the video description for further information and documentation on the topics of this tutorial.